Well, it's an ambitious title, ambitious project. We will see what happens in the next few years. Hopefully, we will at least make some dent into the state of affairs in data and AI infrastructure today. So what do we mean, composable, malleable, and lean compute infrastructure? Before we get into that, I want to briefly introduce myself and my co-founder, Sami. We are co-founders of Sinata, and we founded our company in 2022. We raised $4.3 million, and we have been working on Sinata for the last 2 years. We are headquartered in Austin, Texas, and we are blessed to be the part of the DataFusion community because we have wonderful people supporting us, including Andy Grew, who is the originator of the DataFusion project, Wes McKinney, Arrow and Pandas person, and Marcin Zukowski, co-founder of Snowflake. So I think the team is good. The goal is ambitious, and at least I'd like to think that we'll contribute some good technology. So we are a team of 13 people, and we have 4 machine learning people, 3 data people, and 4 product people. Okay, enough with this stuff. So what are we really doing? What is the problem we are solving, and how are we using DataFusion to solve this problem? So the problem we're solving is that building any kind of data application is starting to be a very complex undertaking. This is a chart from Matt Turk, and if you look at how the ecosystem was in 2012, it was like, okay, a bunch of tools, still a busy PNG file. But if you look at the complexity of tooling in data and AI infrastructure today, it's crazy, it's bananas. And today, when you want to build a platform for your data applications as any kind of infrastructure effort, you have to deal with this. You have to put together maybe 20, 25 different tools to arrive at a coherent infrastructure. So that's the problem you're solving. We think that the root cause of this is that the core technologies in data and AI are coming from a time where the prevailing technical assumptions was different from today. What do I mean by that? Well, if you look at how Spark works and what are the core technologies of Databricks, and when Matei Zaharia actually thought about how Spark should work, we lived in a world where everything was around Java. Cloud native didn't exist. Rust was maybe like an idea in somebody's mind. And machine learning was a very different machine learning. We had SVMs and very small models and such, right? Batch and streaming were like very different modalities of computation. So all of these things actually became kind of technical assumptions as people built these core technologies. And as we made progress along the way, guess what happened? Okay, this old technology is not good enough, so let's invent another tool. Let's invent another tool. Hey, there's this thing called observability now. Let's add another tool. So this keeps piling on, and that's what what you end up with. So every now and then, I think in our industry this happens, and somebody has to come and say, okay, we have to rethink this whole thing. Are we gonna be those guys who rethinks and become successful? I don't know, but I think it's a nice problem to work on. Okay, so let's think about a concrete data app. Okay, I want to create a traffic forecasting app, and I'm probably getting my traffic data from some real-time stream. I'm using tools like Kafka for processing Flink. If I have some machine learning model that looks at the traffic data and tries to make some predictions. Okay, I have some model deployment and inference. I have a training infrastructure because forecasting models have to be updated. You cannot keep using the same old model. And then, okay, if you have any kind of machine learning model that scores data on a continuous basis, you have to have monitoring. Then you have all of these questions in your mind. Okay, now, am I gonna have what kind of engine am I gonna use? It's gonna be Flink or Spark, or what kind of SQL dialect am I gonna use? How am I gonna update my models? How big is my model? What kind of GPU stuff do I need? What happens if training fails as I'm trying to swap in my new model? It's horrendous. But that's how, how we work today, because there's no other way. So how do we try to solve this? Well, you can guess. We are trying to build a new Spark 2.0 that has a lot of these features built in, so that you don't have to bring together all of these tools. And DataFusion is at the center of this new engine. So why did we choose DataFusion? And you already explained this. It's like LLVM for data systems. That's exactly what we needed. You cannot build Databricks 2.0 with $4 million. That's a pipe dream. It's impossible. You have to rise on someone else's shoulders, and that someone else is DataFusion for us. By the way, he keeps saying some people don't like this LLVM for data systems analogy. I love it. That's why actually we joined this project. So I think it works for the right nerd people. So keep using that analogy. It's very foundational, yet it has like a lot of out-of-the-box features. It's Arrow native, Python friendly. You can really, like, we maintain a fork. We have a lot of like features that don't belong to the core, but even maintaining the fork is not that hard. Typically, when you're trying to maintain a fork of such an active project, it's almost impossible. We can do it with a 13-people team, which is a testament to, to the code of DataFusion. It's performance. It has a very vibrant community. We have the small list of companies that, build on top of DataFusion. And like, this is old. I'm sure there are like a lot of others now. So thanks to DataFusion, I think we will be able to deconstruct that mess of a diagram that you saw before. All right, so obviously when we first joined, DataFusion was not like what it is today. I think it had around like 2,000 stars, and like it didn't even have like window function support and like many fundamental things like that. So this is like some of the contributions that we did for DataFusion. And okay, I think Sinata is a big contributor, but if one company can do this, think about the others. The project is really going very strong. And I think it will only get stronger and it will get more capable. So I'm super excited if this is what we can do with a 13-people team and only like 4 of us are actively, contributing. Think about the future. I think the future is bright for DataFusion. All right, with all of that added to DataFusion, now you can actually build things like Spark 2.0. So you copy and paste some weird left join, whatever that runs on data, on like at rest data in Postgres, right? Copy and paste it, no changes, no weird syntaxes, no like explicit watermarks or stuff like that. It runs on Kafka. You can have arbitrary join conditions, and the planner is actually smart enough to say, hey, these join conditions define a sliding window and there's some table ordering, and I can, exploit that table ordering with these join conditions to prune my buffers. All of that you can build on top of DataFusion. That's how you arrive at a state where like, data at rest, streaming data, I don't care, right? And the planner will actually tell you if that query is not executable, let's say stream ordering is not like friendly to your join conditions, it will tell you, it will say, this is theoretically not executable. So you can build stuff like this on DataFusion. So this is the, the compute engine part. Obviously, when I say we want to build Databricks 2.0, that's not the only thing Databricks does, right? So you have to add a bunch of other features. So some of the other features that we're working on that complement and integrate with DataFusion is how do you get AI into this, right? Like, let's go back to our motivating example, forecasting. You have a forecast model that's not like a if, case, when, whatever. It's AI model. It has to actually run on data that goes through DataFusion. How do you put it inside DataFusion? All of that, somebody has to think about it, and there has to be like low friction ways to do that. So we have been working on all of these like purple boxes over the last 2 years. our open source work is directly going upstream. That's why we made that many contributions. There are some stuff that don't belong to the core. It's in our fork. It's called Aras. Maybe we will open source it someday as a separate project, or maybe a DataFusion plugin. And I'll probably want to talk about it with Andrew at some point. And then we have like all of these AI related stuff. How do you actually compile an AI model into a UDF that speaks Arrow, right? Somebody has to do that. And all of the enterprise features, observability and security and blah, blah, blah. So I'm only gonna talk about the parts that I think it's cool. I'm not gonna talk about like role-based access control. I don't wanna bore you. But you can actually integrate some very interesting stuff with DataFusion. It's that flexible. So, okay, let's go back to our example, forecast. It's not a out-of-the-box function that lives in DataFusion. You probably need a machine learning model that will actually take in arrow data, and then you have LSTMs, whatever you have inside them, transformers. So how do you make it so easy so that some Python ML engineer can just write code that looks like this, and then some data engineer can just use it inside DataFusion? There has to be some sort of a compiler, right? Or something that actually takes in this Python code and whatever it runs on, maybe JAX or something else, and does all of the necessary conversions. So we are working on that, and that's going to be open source. It's a separate project. It doesn't belong to DataFusion core, but it will integrate with DataFusion core. And you will be able to actually, either adapt existing models as UDFs into DataFusion, or you will be able to create your own models like Keras or Torch, and then you will be able to expose them as UDFs. So the end goal will be aligning any kind of ML model into DataFusion. This is also ambitious. We will first release a version that doesn't create arrow UDFs directly. It will just have limited functionality, but like I think in the next 6 months to a year, we should have this ready to go with upstream DataFusion. So that's one cool thing that we're working on. Another cool thing that we are working on, which you guys will be able to use hopefully in the next 6 months, is the Workbench. It's gonna be a Notion-like thing that you can do brew install Sinata, and you'll be able to have this DuckDB-like experience when you're building your data app. So it's not a static query. You're not experimenting on ad hoc queries, but you're composing multiple queries together, and you'll be able to utilize that ML stuff, so you can try out like end-to-end pipelines locally on your machine, and it will have DataFusion embedded inside it, obviously. So that's the other thing we're going to release, and I think the first version will come out probably before the New Year's. And hopefully, if you're successful as a company, once you all iterate locally to create your data app, you'll be able to scale it to the cloud, and it will run in a distributed manner. So this will hopefully is going to be something that you guys will be able to play with in the next 3 months or so. So road ahead, what's next? I talked about a lot of ambitious stuff. We will keep working on those, and the community will keep working on other things. Here are my thoughts on what we should focus on. I mean, we will contribute stuff. There's no letting up. We're going to keep contributing. But I think as a community, we have to focus on a few things. For the first thing we should focus on is, I think, performance. I already said this on GitHub many times. I think it's very important. Architecture, these are very important things, but at the end of the day, people are like, oh, I look at ClickBench and like DuckDB is 5 times faster. You don't want to be in that position. Like, you always want to be competitive. I think we made very good progress over the last 3 months or so. I remember me talking with Andrew about this like a year ago. At the time, it was horrible. Like, we were really behind. Now we're like almost neck to neck. A little slow still, but almost neck to neck. And I think we'll do even better. Another thing we should focus on, in my opinion, is easier extensibility. Like, today, it's still not very easy. I think we recently had a proposal about this. I'm super excited. I'm not sure, like, I haven't thought through, I'm not sure like what is the right way to go around these things, but I think it has to be done in some form. Increasing maintainability. I think one of the challenges we have as a community is we move very fast. That's very good, but sometimes it makes it hard to maintain. So we have a lot of regressions. I think it has increased in the last 3 months or so. That's a failure of us as a community. I mean, it's not terrible, but it's not as good as it should be, right? So we should be careful about this. Another thing where we have to be careful about is like, DataFusion is so flexible, it can go to many places. It cannot go to all places at once. So we have to make sure that the core is the core, right? So I don't like, I don't like this gatekeeping stuff, but I think some gatekeeping will have to be done at some point. In terms of like, hey, let's have plugins. Let's have a plugin system. What's going to be in a plugin? What's going to be in core? These are the things that I think we'll need to discuss. And lastly, this is related to keeping the core simple. I think we sometimes make unnecessary code and API churn. As a maintainer of a fork, I get to see this very easily when it happens. If we are a little bit more careful when we go through like API changes and stuff, I think it will be even better for adoption, because there will be a lot of people who will be using DataFusion in ways that we can't even imagine right now, right? So we have to be friendly to them. Interestingly, when we first joined 2 years ago, I think the community was more careful about API changes. Now I think we are making more API changes, which is fine if they're warranted, but I think we always have to be like conscious about it. So these are my thoughts about how what are the challenges for us, and I think we'll solve all of them in wonderful ways. We've come this far. That's basically, I think, the gist of our talk. I just want to give a short plug. We're hiring people. Obviously, the project is big. 13 people will not cut it. We need smart people. We need people who like to solve hard problems, and we are going to be growing our data infrastructure team, and almost half of the responsibilities is upstream data fusion. We tend to upstream data fusion quite often. So if you want to work on upstream data fusion, if you want to build Spark 2.0, come talk to me or Sammy, my co-founder. Or if you're excited about like, hey, I want to put AI into data fusion and what's the best ways and this compiler stuff, come talk to us. Those teams are going to grow. And I think that's the end of the plug and end of the presentation. Thank you.